1980.
We are NASA employees from the year 2012. If you don't believe us, look what I can do. I'm touching it. I'm controlling it with my finger.
Anyways, if you found this video, it was probably on the front steps of the White House. Congratulations if you found it.
We have made this video to inform you of our great mission. We call it the Magnetosphere Multi-Scale Mission.
Or MMS.
In this mission, we will be sending out 4 probes to go around Earth's magnetosphere in a tetrahedron formation. We will be collecting information concerning magnetic reconnection.
The magnetosphere is an area surrounding the Earth's outer region of the atmosphere. Earth's magnetosphere was formed because Earth's core is made up of iron, which is a necessity to create electron flow. And, well, magnets. Yes, electricity is directly related to magnetism. Ions are trapped within radiation belts. And when these particles and belts collide, they create auroras, beams of light. And we can see these auroras at the North Pole, and we call them the Northern Lights. Our Earth's magnetic field is an obstacle to solar wind, which is plasma, an ionized gas that contains ions and electrons, blown away from the sun. Thus, the solar wind flows around the Earth and shapes the magnetic field. Sometimes the solar wind forms a bow shock, a collision between 2 winds, which happens a few Earth radii away from the front of Earth's magnetic field. The boundary of the field is called magnetopause. The region between the magnetopause and the bow shock is called the magnetosheath. The Earth's magnetotail is a long cylindrical part of the Earth's magnetic field. Now, while magnetism and space are both very interesting, there is an important reason to this assignment.
The keyword we're looking for is CME.
CME stands for Converse Magnetoelectric Effect.
Now, CME is what happens when a huge solar wind is released into space. When the shockwave is directed towards the magnetosphere of Earth, it forms a geomagnetic storm that can disrupt the Earth's magnetosphere, and it compresses the magnetosphere on the day side of Earth and stretches the night side. Now, when the magnetosphere reconnects on the night side of the Earth, the energy release goes up the atmosphere, and these solar flares can disrupt not only radio transmissions and GPS, which is something we have in the future that tells us where to go,
which is very annoying,
but it can also damage satellites that we have up into space, and those satellites, the Earth gets massive, huge power outages from this, which causes a lot more damage than you know. NASA and other organizations around the world have decided to create this program and launch this mission, not only to figure out or to learn more about Earth's magnetosphere and magnetic reconnection, but to also figure out how to maybe prevent these power outages before they get, potentially worse. We just really don't know. We need to learn more about it to figure out how to prevent it. Our launch date is scheduled for August 2014 at the Cape Canaveral Air Force Station, located in Florida, the Eastern Test Range, which is 2 years from now.
We don't know when we'll be sending you our next video update. It will most likely be after we've launched those probes for the MMS mission.
Although, for you, it may be tomorrow, or a few days later, or maybe even a few years. But just keep looking on your footsteps for our VHS. We will surely be sending you.
We will be ending this video here, so thank you for listening.
Oh, and before we go, don't believe any of that Y2K stuff or any of the other conspiracies that the world's gonna end or whatever, because it's 2012 and we're still alive.
Goodbye, citizens of 1980.